Page 92. Exercise 3, part D. The question shows that Sn is equal to AC plus dB. You have to prove that this vector is equal to the sum of these two. How to prove it? How to prove it?
Can I tell you what did I write?
Yes, sure. Start.
أنا ببارت C I did it in another way وطلع معي different answer ما بعرف ليه بس I used it in part D.
خلينا نشوف. Yeah, start. How did you find it in part C in different answer?
Okay. AS equal AB minus AC plus AD.
Yeah, just one moment. خليني بس اكتب معي for review. AS is equal to AB minus AC plus AD.
صباح أستاذ.
يسعد صباح. Okay, continue.
Okay. ال AC هي CA negative AC هي CA.
Okay.
So I took CA and AD.
It's AB plus CA plus AD. Okay, you took which two
CA and AD
Okay, so it's AB
plus CD.
plus CD. Okay, then
هلا I didn't أنا complete هون لأنه I left it هيك لأنه I used it in part D.
ما في مشكلة.
Okay.
أكيد صح.
In part D.
In part D.
Sn equal AC plus DB. I added point A.
On vector Sn.
Yes.
This is the key. Whatever you wrote in part C, AS, you wrote it in this way or in different way. Okay. The key to solve this exercise or to prove this vector is equal to this is to insert point A here. Why to insert point here, A? You'll get vector AS or negative AS, it's not important, and vector AN that you already have in parts B and C. Regardless the way you, whether you wrote it in this way or in a different way, both will give you the same answer, will lead to AC plus B plus DB. Okay.
Yes.
Right. So A or Sn
is equal to SA plus AN.
Plus AN. Again here, to remind you, when you have to prove an identity or to prove that vector equal vector or equation, whatever, okay, you start from one side to get the other side. She started from Sn. Insert point A. To insert point A, you'll get SA here. Insert A between S and that. If you insert point A, you'll get SA plus AN. SA, which is negative AS. And you have in part C vector AS. AN, you have in part B vector AN. Okay, continue.
Okay, SA هي the opposite of AS يعني which is
AS.
Yes.
AN.
Okay. Yes.
Good.
Which is equal to negative vector AB, negative vector CD, plus
Okay.
2AB.
We can use it, but I'm going to replace AS by its value as it is given in the exercise. And then I'm going to continue in the same way you did. I can't say it's not true. It is true. Okay. So replace AS by its value. That's given in part C. It's AB plus AC minus BC. Since here you have negative AS, you change all the signs. You change all the signs. So you get negative AB plus AC minus AD. This is vector AS. Negative AS, you change all the signs. Okay? طيب what about vector an?
It's equal to 2ab.
Vector an, it's 2ab. طيب okay, plus 2ab, because in part
Okay.
just one moment. This one in part by part b, an, vector an, we proved it is equal to 2ab. Okay, right. So it is equal to
Okay, 2ab
2ab
minus
minus
ab.
ab, 2ab minus ab, it is ab. And for this one, the same step as you did, it's dA plus dc, right? Which is equal to dc.
Yes.
يعني انت هون حطيت minus cd which is equal to plus dc, صح؟
Yes.
Okay.
صح.
So first of all, thank you, Nick. Negative AB plus 2AB, the answer is AB. And for this, minus DA, it's positive DA. Okay, so it's plus CA plus AC plus DA. AB, AC, we need it. The answer should be equal to AC plus something. Now, AB plus DA, AB plus DA, what will be the answer? It's DB plus vector AC. I, between brackets, DA plus AB, DA plus AB, that's equal to DB. Okay, so here we started from the left side, we got the right side. Can you find it in a different way? Yes, you can find it in a different way. No need to replace AN by 2AB. Replace AN by its value as it is given in the exercise. But the steps will be almost the same.
Yes.
Any questions?
No.
Okay. Let's move to exercise number 5. May I erase?
أستاذ.
ABCD is semi-regular hexagon, where OC is equal to vector V and OD is equal to vector U. Okay. Like, what is a semi-hexagon? What is a regular hexagon? What do you mean by a regular hexagon?
It is made up of 6 equilateral triangles.
6 equilateral triangles. Okay, if you divide it, it will be 6 equilateral triangles. But the meaning of regular hexagon, or in general, regular polygon. When you say regular polygon, regular.
أستاذ صوتك عم بقطش كتير.
عندك بس ولا عند الكل؟
لا أنا عندي منيح.
كان انترنت من عندك. بس بجمع الأحوال وين بتعلق خبرني. اوكي؟
أوكي.
هل ما بتعلق خبرني. اوكي. Regular polygon, when I say regular polygon, that means it is a polygon with all sides equal, all angles are equal. Okay. A regular triangle, it means equilateral triangle. A regular quadrilateral 4 sides, which is the square. 4 sides equal, 4 angles equal. A regular pentagon, 5 equal sides. Pentagon, 5 sides, someone doesn't think okay. All the sides are equal. All the angles are equal. This is the meaning of regular. Okay. Hexagon, polygon, as I said, number of sides. Okay. Or as you already know. Right. Hexagon, we have 6 sides. Regular hexagon, we have 6 sides. You have all the sides are equal, and all the angles are equal. You said it's formed by 6 equilateral triangles. Yes. For one reason. Draw the diagonals here. 1, 2, 3. In fact, we have more than 3 diagonals. This is another diagonal, and this is another diagonal. We have 15 diagonals in this one. 62, 5C2. No, which 15? Okay. Right. Each triangle here, let's say OAB, B, C, D, E, and F. Okay. Each triangle here is equilateral triangle for one reason. For one reason. Here, regular, from the word regular, لو ما كان regular لا. Hexagon 6 sides, only 6 sides, هذا 6 sides. هذا hexagon, but not regular. Okay. 1, 2, 3, 4, 5, 6, not regular. Okay. I'm saying for regular. The sides are equal. Also, these segments will be equal. OA, OB, OA, OB, OC, OD, OE, and OF will be equal. The measure of each angle here, each angle 1, 2, 3, 4, 5, 6 will be equal to 360 divided by 6, which is equal to 60 degrees. Will be equal to 60 degrees. By the 60. And we have 2 equal sides. Then this triangle is equilateral. 2 equal sides. And angle is 60, then the triangle is equilateral. Then this side is equal to this is equal to this. On the same idea, all the sides here will be equal. كل اللي انت شايفهم هون كلهم equal. Okay? OA, OB, OC, OD, OE, OF, AB are equal to AB equal BC, CD, DE, EF, and FA. All the angles here are 60. 60, here 60, and here 60. This angle is 60. كلهم 60. Okay? This is the regular hexagon. Good. Semi-regular hexagon. Semi-regular hexagon. This is a semi-regular hexagon. Just like when we say semicircle. Okay? Good. Now, given this semi-regular hexagon, and by the way, to start to draw a regular hexagon, or in general a regular polygon, let's say of 7 sides, or let's say of 9 sides. If I ask you to draw a polygon, a regular polygon of 9 sides, the easiest way is to draw a circle from the center here. Start by a given point. This is the first point on the polygon, A. The angle is 360. You divide 360 by the number of sides by 9, so you get 40. So from this point O, you draw 40, and then continue. Another 40, another 40, 40, 40, 9. 1, 2, 3, 4, 5. Of course, this one will be 40. Here is the regular hexagon or regular polygon of 9 sides. All these sides will be equal. All these sides will be equal for one reason. If you consider, let's say this and this, these two triangles are simply congruent. Let's say B and here C, OAC and OAB are congruent. We have one side in common. OB is equal to OC, radii of same circle, and this angle is equal to this. They are both 40. Then the triangles are congruent. Then AB is equal to AC. Same idea for the other triangles, right? So here, the figure you get will be a regular polygon of number of sides 9. You need to draw sides, number of sides 10. Same idea. Okay, back to our exercise. You have O, A, B, A, D, and here vector C, you have point C. Here we have vector V. Vector V, it is OC. And vector U, it is OD. Okay, U, it's OD, and V, it is OC. Part 1. Find, in terms of U and V, the following vectors. Vector OA. Who would like to start?
May I?
Sure.
اوكي اول شيء استاذ من الجيفن يلي اعطيتنا اياه يطلع انه DCOA is a rhombus since DC equal OA و OC equal DC.
Sure. So OADC
فبيطلع
is a rhombus. Good. In particular, it's a
و
parallelogram.
DCPO كمان.
Right. Okay.
اوكي OA هي OD plus DA
OA, it is OD
plus
plus
DA.
DA. OD plus DA. So if you insert here point D, insert point D. Continue.
اوكي OD هي given U.
OD, it is vector U. And what about DA?
DA هي negative vector V.
It's
لا,
negative
since,
vector V. OC and DA are opposite vectors.
Yes.
Okay, so it's negative vector V. So it's U minus V. Perfect. Thank you. So here,
ترجع تعيدها شوي.
here the question, write it in terms of, write the given vector in terms of U and V. To write it in terms of U and V, or sometimes they say write it as linear combination of U and V. It means here, write it in terms of U and V, something, some relation between U and V. Relation between U and V.
Yes.
2U minus 5V, 3U over 2 plus V, or let's say 5U only, it means plus 0V. Okay? Some relation that contains U and V. Good. So here, if you insert point D, why to insert point D? Because if you insert point D, you get OD. OD, it is U. Done. What about DA? DA, it is negative vector V. هذا DA وهذا V. DA and OC. These vectors are opposite vectors for one reason. Here, because it is a regular hexagon, all these sides are equal. All the sides are equal. So OADC is a parallelogram. It is a rhombus, but at least it is a parallelogram. For the opposite vectors or for the equal vectors, I just need the parallelogram. Moreover, it's rhombus, okay, كتر خيره, but I need the parallelogram. So here, between brackets, I can say OADC is a parm. It means that AD or DA, it's equal to CO, which is equal to negative vector V. Right? So DA, it is negative V.
Yes.
Clear?
Yes, أستاذ.
What about the second one? AB.
أستاذ مش لازم تطلع 2 vector DC.
Okay.
أستاذ ما نستعمل إسا الهكزاجون شي هيك صح؟
ليك استاذ.
يس.
اذا بدك واحده بيطلع فيها مضبوطه بيقول انه لا في عندك هون justification في شيء ناقص. انه I said here OADC is a par لان انا منين جايبها هي؟ OADC it is a par for one reason. For one reason. Because you have OA is equal to DC. OA is equal to DC and OC is equal to DA. Or if you want, the four sides here are equal. OA is equal to DC. It's equal to OC is equal to DA.
Okay.
Since the figure is a semi-regular hexagon.
ايه بعرف بس قصدي بالاي بي ما نستعمل كل الهكزاجون هيك قصدي.
Yeah, how?
أنا؟
أنت أو غيرك.
فينا
استاذ I can try بس I did one.
Just a moment. أول ما ببلش خليني أكتبهم. automatically صح. ممكن تكون فاهمينها صح. OA أو مش OA. ABCD is a regular hexagon. ABCD is a semi-regular hexagon. It means that OA is equal to OB, is equal to OC, is equal to OD, is equal to AD, is equal to DC, is equal to CB, and both OADC, OADC, and ODCB or OBCD are parms. And then these two are parms. Okay, تكون هيدي واضحة عندكم. هون figures عنديهم parallelograms. Okay, طيب. So in part 1, OA, as your friend said, it's OD plus DA, which is equal to OD, it is U, minus DA, it's V, minus V. Justification, صار موجود قدامك because it's parallelogram or you have parallelogram. Okay. To write it in
يجر
details.
بالاي بي.
To write it in details, DA is equal to CO لأنه parallelogram, which is equal to negative V here, since OADC is a par. هيك خلص ما عادش في واحد يشك بهيش.
صعبين كتير استاذ.
لا مش صعبين ابدا. From the graph I wrote the justification in details. انه واحد بيتعود عليهم. But the graphically لا, it's very easy. Like I said yesterday, the idea, insert a point, okay, we are going to apply it a lot. Insert a point. It depends which point I have to insert. We don't have a rule. It depends on the exercise. By the way, here we can solve it in a different way. We can find OA in terms of U and V in a different way without use of point D. You can say that OA is equal to CD. OA is equal to CD, and CD, it is OD minus OC. CD, it is OD minus OC. The difference between two vectors, what we explained last time. Okay. The second one, AB. AB. We have one easy way to find it. In 2 steps, we can find it. In 2 steps, equal and then equal the answer. Try, Rebal, yes.
نحن انه قلنا انه هيك انه هو semi regular hexagon، يعني صارت ال AB equal AD plus DO plus OC plus CB.
Would you please repeat? AB is equal to
AD plus DO plus OC plus CB.
This is not because it is a regular hexagon. This is true for any quadrilateral ABCD. Because here you are applying Chasez relation.
Yes.
Okay, then.
إسا بنعملهم replace. إسا حسب ما فهمت replacing تبعها، فهمت إنه مثل ما قلنا ال OADC هي parallelogram، يعني ال opposite sides are equal، يعني ال DA equal ل OC equal V، يعني ال AD هي V.
Good. By the way, we can continue from. Nice idea. Right. So here, insert point D, O, and C. Look at this vector, this sum of vectors. AD plus DO plus OC plus OB. Here we have inner points are equal. Inner points are the same. Inner points are the same. Then the sum will be equal to AB. Good. Now, according to our figure, AD, vector AD, it's equal to vector OC, which is what? Vector V.
V. Yes.
And DO
هي negative U.
It is negative U, because here you have U, it is OD. Then DO, the opposite, it is negative U. So minus U. OC,
هي V معنى إياها
it
نحن.
is V. So plus V. And CB,
هي كمان negative U.
CB, it is negative U. CB, it is equal to DO, which is negative U. So minus U. Then the answer will be equal to negative 2U plus 2V. It's correct. We have another way, simpler than this. هلا جد بيطلع هيك طبعا كيف بده يخطر على بالي انه I have to insert a point. Why a point I have to insert? We don't have a rule. You have to try. You have to try.
طب استاذ فينا نقول AB equal AO plus OB دغري؟
AO plus OB
ايه
فينا أكيد. Like this is geometry. I can't say that this method is true, this method is false, or from the beginning. I don't know. You can write AB is equal to AO plus OB. Like, will this lead to an answer? I don't know. According to your steps, according to what you write, if it is correct or not correct. But I can say here that we have another method. AB, it is 2 times AO. Right? AB, it is 2AO from the figure. Is it clear or not?
Yes.
As vectors, please you have to differentiate between magnitude and vectors. Okay? AB
استاذ مش مبين الكاميرا
اوكي بعرف
على
ايه شيء عارف بس بدي الجراف عشان هيك مش مطيع. Vector AB, it is 2 times vector AO. Be careful. When you talk about equal vectors, direction, sense. I can say as magnitude, okay? Magnitude. AB, magnitude of AB, it is 2 times magnitude of OA. As magnitude, it's true. Vectors, no, it's not true. Because AD and 2OA, they have opposite sense. I can say magnitude of AB, it is 2 times magnitude of AD. Hey, true. And length, this segment is twice this segment. This segment is twice this segment. But as vectors, no, it's not true.
Yes.
Okay. Now here, vector AB and vector AO. Vector AB, it is 2 times vector AO. Vector AB, it's 2 times vector AO. Okay. طيب. نعم. يلا صار في وقت الكلام. بدي كان أول وحدة تفهمها جرافيك. AB, it is 2AO, but you have AO or OA, the opposite. So it's negative 2OA, right? Negative 2OA, and you already have OA, it's U minus V. So it's negative 2U minus V.
استاذ حتى اذا عملت ال AB equal AO plus OB كمان ظبطت معي.
أكيد.
ايه
دي طريقة. Because AO, you already have AO. we have OA. AO, it means the opposite, so negative U plus V. Okay, the opposite. Change the signs. Okay. Now, and for OB, the same way. As we found OA, you can find OB. نفس الطريقة ما تغير شيء. OB, you can insert point C. It's OC plus CB. The same idea, the same way as we did here. But I think that the easiest one is this. Simply.
Yeah.
2 times and multiply by 2. That's it. Okay?
Okay.
Daniel, Jad.
نعم أستاذ.
شو؟ بدي أعرف.
شو؟
Clear or not clear?
يعني هيك.
هلا ليك اسمعني شوي. عم بحكي للكل. ما تبلشوا هلا تستوهموا. ويا لطيف شو صعبين ويا لطيف شو معقدين. انتوا أول مرة بتاخذوا فاكتورز. اوكي؟ بنتعود عليهم شوي شوي. اوكي؟ الحالة النفسية ما إياها تكون تعبان. الواحد بيتعود عليهم شوي شوي. مش عم نمشي بسرعة. مش عم نقول بكره في عنا كويز يا لطيف. لا. بدنا أول بوينت إنه to understand well. اوكي؟ على البراكتس كل الأمور بتتغير. على البراكتس كل الأمور بتتغير. اوكي؟ جاد؟
اوكي استاذ.